So if you look back at what we did before the break, so before the break, we took what we call in the actuarial literature, we took a prospective point of view. So prospective viewpoint when calculating the policy values. So when calculating the TV. And why was our point of view prospective or looking into the future? Because what I said was we have our timeline, we have a policyholder hx at time 0, we've got time point t, our policyholder is hx plus t. So what we do with the TV when calculating the TV is we put ourselves at this position and we look into the future, right? We look into the future. So this is our future cash flows, and we're going to value these cash flows at time t. So we're going to do the valuation over here, and that will give us the TV, right? So that's one way of doing it. What I'm now going to show you is a retrospective point of view in order to calculate the policy value. And we will see that both viewpoints lead us to the exact same policy values, so to the exact same provisions. But of course, the way we approach this valuation exercise is different, right? So right now, what we're going to do is we're going to take a retrospective viewpoint. A retrospective viewpoint, and we're going to continue with exercise. We're going to continue with exercise or example 7.1, right? So if I continue this, and if I look at example 7.1, I have my endowment insurance with a duration of 20 years. I had a 500,000 euro sum insured, so that was for my endowment insurance. And this product was issued to, what was it, a 50-year-old. And what I'm now going to do is I'm going to ask myself what has been paid in the past and what is the accumulated value at time t of what has been paid in the past. So I'm going to take a viewpoint where I say for this particular endowment product, I've got my 50-year-old at time 0. I'm going to put myself at time 10. I'm 60-year-old then. And in terms of the premiums, I know that I paid a premium equal to P at time 0. I paid a premium P at time 1, and so on. And the last premium to take into account here is the premium P that is paid at T equals 9, right? I do not take the premium paid at time 10 into account because the convention is that we calculate the policy value at time 10 right before the premium payable at time 10 would actually be paid, right? And now what I'm going to ask myself is, what is this stream of premiums? What is its accumulated value at time 10? So I'm going to value the whole thing at time 10. So I'm going to go from time 0 to time 10, from time 1 to time 10, and so on, from time 9 till time 10. That's for the premiums. So if I write that down, then the accumulated value is, say that I had n policyholders, so that's the number of contracts that I sold, that I issued. Then I have n times p, which I paid or which I received at time 0. So that grows to, with 5% interest, that grows to n times p times 1.05 to the power 10. Then I know that P50 times n, policyholders will survive until time 1 and pay the premium there. So that grows to the following amount. And then for the premiums that I receive at time 9, I've got 9 P50 multiplied with the 1 year interest rate, and that is the following amount. So this is the accumulated value actuarially the accumulated value at time t is 10 of the premiums. Yeah, does that make sense? So I take into account that I start with n policyholders at time 0. They pay the premium P. Then I've got n times P50 policyholders expected to be alive at time 1. They pay the premium and so on and so forth. And I let this cash flow, I let that accumulate until time 10. And now we're also going to take the other part of my cash flow into account. And that is, I'm going to ask myself, what is the present, or what is the value at time 10 of the insured benefits that I paid between time 0 and time 10, right? So if we look at the benefits, so if I would picture that as well, then I've got a visual like this. So again, at time 0, I've got my 50-year-old, and I've got at time 1, 2, etc. And here I am at time 10 with a 60-year-old, right? So if I now say, what did I pay at time 1 in terms of the death benefits, and how much is that now worth at time 10? That's the question over here. So here I know that I paid the death benefits of 500,000 euro at time 1 for all the policyholders who died between age 50 and age 51, right? So I paid this 500,000 euro, and I need to value that now at time 10. I paid the 500,000 euro at time 2 for a certain number of policyholders. I need to value that at time 10. And then the last part here is that I actually, at time 10 itself, also had to pay this 500,000 euro for a specific number of policyholders. So putting that all together, what I get here is that if I look at the accumulated value at time 10 of the benefit cash flow, then I will get 500,000 times n times Q50, because that's the probability that you will die between time 0 and time 1. So if I do n times Q50, I've got the expected number of policyholders who will die between time 0 and time 1. And for them, I will pay the death benefit of 500,000 euro at time 1. So if I value this at time 10, I need to multiply with the 9-year interest, or the 9-year inflation factor. So that's 1.05 to the power 9. And I can continue like that. And finally, I will retrieve this probability, right? So what is here the last term in this expression? This is the probability that you will survive until age 59 and will die before reaching age 60. So if I multiply with my n policyholders, that gives me the expected number of people who will die between time 9 and time 10. And for them, I need to pay the 500,000 euro at time 10. So if I calculate the accumulated value at time 10, there is no inflation factor to be taken into account here, because this amount is paid at time 10 already, right? So that's how you should see it here. So this is payable at time 1, whereas this last one is payable at time t equal to 10. Okay, whereas here I was working with this thing is payable at time 0, and here the last term was payable at time 9. T is 9. Okay, so if I put both cash flow streams together, I got the accumulated value at time 10 of what has happened in the past, right? So that's my retrospective point of view. So if I put it all together, I get the following stream. So putting it all together, I've got n times p times, so I first look at my premium stream, I value this at time t, and I subtract the outflow, sorry, in terms of my debt benefits. And I've got something like this, right? So this is what I get. That's the value of the cash flow stream done in the past. That's the value at time 10, okay? And then I know that the part of the premium comes with a plus because that's what I received, and the part of the debt benefits that comes with a minus because that's what I had to pay to my clients. So what we're going to do now is we're going to rewrite this expression. I can put the 1.05 to the power 10 up front, multiplied with n times p, and then I'll retrieve an expression like this. Right? Minus then something like this, right? So I massage my expression a little bit. I put a certain, I put this guy up front, I put this guy up front, and I'm left with something in between the brackets. So the whole idea is now that I can recognize the expression here between the brackets as the EPV of a particular insurance or annuity product, right? So if I look at the expression here between the brackets, I recognize the EPV of a 10-year annuity due issued to a 50-year-old. See this? If I look at the expression here between the brackets, I recognize the EPV of a term insurance issued to a 50-year-old with a duration of 10 years. So putting that all together, I have 1.05 to the power 10 times n times p, and then the EPV of my term life annuity, minus then, I'm going to do it like this, minus the 500,000 euro multiplied with my 10-year term insurance. Yeah. So here we see that this guy, that's the expression that we had over here, and the expression that I recognize here, that is what I had here between the brackets. Yeah. And I know if I do the maths, if I do the numerical calculation, because now I've got an interest rate, I've got the P, which I already calculated in this exercise. I can calculate numerically what is the EPV of this 10-year life annuity, of this 10-year insurance product. So I can figure out that numerically, this is equal to the following number. Okay, and I see that's the accumulated value of the cash flow stream from the past accumulated to time t. So this is an amount of capital, and this is a fund that we build up in this setting. Now, how does that relate? And that's the final step here. How does that relate to the insurance, to the policy value at time 10 that we calculated before the break? Yeah. So before the break, we said that the prospectively calculated policy value, so that was the expected value of 10L, right? Or I should better write the L10N. For this particular contract was about, what was it again? 190,339 euros. So how can we relate this value, which we calculated before the break with a prospective mindset? How can we match that with the fund that we accumulated if we take a retrospective point of view with this fund that we calculated over here? So that's the final consideration that we want to make. Yeah. So here is how we can do that. So if we look at time 10, so at t is 10, we've got in expected numbers, we've got 10p50 times n policyholders who survive until time t equal to 10. So what do? In the fund, in the accumulated fund, there is a share of, so this was the total amount in the fund, and the number of people among who this should be spread is given like this. So if you calculate this, you get a value worth 190,339. So that's the amount in this fund per surviving policyholder. Okay, and that's exactly why we see that this retrospective point of view here leads to a similar conclusion as the prospective point of view that we took before the break. Yeah? So what I did is I put myself at time 10, I looked back, I said, okay, which cash has been flowing from the insurance company to the policyholder and vice versa? What is the accumulated value of this cash? So what is the fund that has been built up? And I compared it to the number of surviving policyholders, and I calculated an amount available in the fund per surviving policyholder, and you see that that is equal, that corresponds to the policy value as we calculated it before, right? Let me just explain this result a little bit more by building up the reasoning that you see here on the sheet. So how can we understand the result that we've been deriving so far, and that the retrospective and the prospective point of view lead us to the same amount of capital per surviving policyholder? Well, our starting point here on the sheet is the actuarial equivalence. We say we calculate the premium P by asking an actuarial equivalence between the EPV of the premiums in this 20-year endowment insurance issued to a 50-year-old. The EPV of the premiums is equal to the EPV of the sum insured, right? That's what we started from. And now, in order to understand what is going on at time 10, what I'm going to do is I'm going to use at both sides of my equation this so-called splitting identity. So I split up the EPV of the term life annuity due with a duration of 20 years. I split it up into a term life annuity with a duration of 10 years, and then another term life annuity issued to a 60-year-old with again a duration of 10 years, right? And I do something similar here at the right-hand side for my endowment insurance. And so the fact that I choose to do the splitting at time 10, that's of course no coincidence, because that's because I want to say something about the policy value at time 10. So we do this splitting, we know that that is valid. And what we're going to do is we're going to bring together on the one side, we're going to bring together what is happening between age 50 and age 60. So there are the payments that I need to pay. There is the term insurance that is valid between age 50 and age 60. And then on the other hand of my equation, I've got what's going to happen in the future. And in the future, I've got this 10-year remaining endowment insurance issued to a 60-year-old, and I've got another 10 years of premiums that will be paid at the beginning of each year, right? So I'm just rearranging the expression, and I reach the following equivalence, right? So what we can do now is we can bring this actuarial discount factor, this V to the power 10, multiplied with the 10-year survival probability, we can bring that to the other side. And what we get then is, in fact, what I've been doing on the iPad. Because what I've been doing on the iPad was I calculated first the accumulated value of the premiums minus the death benefits. I calculated the accumulated value at time 10. And that turned out to be this 1.05 to the power 10, multiplied with n on the iPad, multiplied with what you see here between the brackets. And then I said that's the fund accumulated at time 10. which I can divide by the expected number of survivors at time 10. And the expected number of survivors, that was this 10-year survival probability multiplied with n. So the n in the numerator and the denominator, they drop, they cancel out. And what I'm left with here at the left-hand side is the share of the fund per survivor at time 10. And here I clearly see that that is then equal to the expression for the policy value at time 10 if I use my prospective point of view. So here you clearly see that if we start from actuarial equivalence, that we reach this, that we can either calculate this policy value with the prospective point of view on the right-hand side, or with the retrospective point of view by calculating the accumulated value of the fund at a certain point in time t, and by dividing that by the number of expected survivors out of my initial group of policyholders at a certain point in time t. So this is a bit of a reasoning where we play with different points of view, either prospective, either retrospective. Of course, when you're asked to calculate a policy value on the exam, it's up to you whether you want to go for the prospective point of view or for the retrospective point of view. I would say that in general, this prospective point of view is the most easy one, but for certain products and for certain choices in the policy design, it can be easier to go for the retrospective point of view. I have no specific example in mind right away, but if you really have the feeling that formulating the prospective view becomes very complicated, then it would be good to have the reflection, but I can also think retrospectively, right? And I can also use that to write down the policy value.